problem states the rectilinear motion of a particle is governed by the equation A is equal to 6t minus 4 meter per second squared when t is equal to 0. The acceleration of the particle is 4 meter per second squared to the left. During the interval from t is equal to 2 seconds to 4 seconds, the displacement of the particle is 20 meters to the right. So determine the initial velocity of the particle. And then the velocity of the particle at the end of the displacement, which is 20 meters, and the position of the particle when t is equal to 3. So we have here our given values. We have our governing equation, which is A is equal to 6t minus 4. And then, all we need to do to find the initial velocity is to derive a formula using the kinematic formula. A is equal to the derivative of v with respect to time. And then we rearrange this formula into dv is equals to a dt. Then we substitute the value of a. We have dv is equals to 6t minus 4 dt. And then we integrate with the limits of v to v sub initial, or v initial, and then the v, and then 0 to t. And then we need to integrate. The integration of dv is just v, so v, the limits of v over v sub the initial velocity. The integration of 6t minus 4 is 6t squared over 2 minus 4t with the limits of t to 0. We need to cancel out this. This will become 3t squared minus 4t. We have v initial, or v final rather, minus v initial is equals to, we have here t3, 3t squared minus 4t. And then we need to transpose the v initial to the other side. We have v is equals to 3t squared minus 4t plus the v initial. This is our formula for velocity. We need to find the initial velocity. And then we need to derive this equation again with our formula v is equals to dx over dt. Then we arrange the formula. Dx is equals to v dt. And then substitute the value of v. We have dx is equals to 3t squared minus 4t plus the v initial times dt. Then we need to integrate. Integration of dx would be x. And then we need to apply the limits of x sub 0, x initial, and x final. And then we have here 0 to t as our limits for time. Then the integration of dx is just x initial is equals to, the integration of 3t squared would be 3t cubed over 3 minus 4t squared over 2 plus the v initial times time. And then limits of t to 0. We have here x minus x initial is equals to, this will be cancelled out. This will be cancelled out, 2t squared. We have t cubed minus 2t squared plus the initial times time. And then, in our problem, it is stated here that during the time 2 to 4 seconds, the displacement of the particle is 20 meters to the right. So, we need to create a limit in here. By the way, this is your formula for your displacement. And then we need to create limit here, x initial is equals to, we have t cubed minus 2t squared plus the v initial times t with the limits of 2 to 4. 2 to 4. We need to calculate that. This will become the change of x, since this will become x minus x initial, the change of x. We have change of x, or this is the displacement here, 20 meters. Then is equals to 4 cubed minus 2 times 4 squared plus the v initial times 4 minus 2 cube minus 2 times 2 squared plus the v initial times 2. And then let's substitute the value of x, summation of x here, into 20 meters. There. So we have this equation here. Then we have already substituted the value of the time, our limits, and then we just simplify. 4 to 3 is 64, and then 2 times 4 to the power of 2 is 32, plus 4v initial, minus this will become 2 cubed minus 2 times 2 squared. So 2 times the 2 squared is equals to 2 cubed, which means positive and negative will become 0, plus v initial 2. And then distribute the negative sign to v initial 2. We have 64 minus 32 plus v initial, 4v initial minus 2v initial. So after that we combine the like terms. 4v initial minus 2v initial is 2v initial. We have 64 minus 32. 64 minus 32 is 32. And then we transpose it to the other side. This will become positive 32. Transpose it to the other side, we have negative 32. And then 2v initial. 20 minus 32 is negative 12. It's equals to 2v initial. Divide both sides by 2. We have v initial is equals to negative 6. This is the answer for our letter A. The initial is equals to 6. And then we need to get the velocity of the particle at the end of the displacement. At the end of the displacement. So all we need to do here is, at the end of the displacement, the velocity, we have the formula for velocity. V is equals to 3t squared minus 4t plus, we have the initial here, substitute this with the initial that we calculated, negative 6. We have 3t squared minus 4t minus 6. Then this is letter B. Just substitute the value of 4 seconds at the end of the displacement. We have 3 times 4 squared minus 4 times 4 minus 6. V is equals to direct calculation. We have 26 meter per second. Since this is velocity and it is positive, the direction is to the right. And then for letter C, the position of particle when t is equals to 3 seconds. So we have the formula here. X minus x initial is equal to t cubed minus 2t squared plus v initial t. We have the change of x. Change of x is equal to t cubed minus 2t squared plus v initial t. So we apply the value of the initial that we have calculated, which is negative 6. By the way, this is meter per second. So velocity to the left. And then we have change of x is equals to t cubed minus 2t squared plus the initial, or we have here times t. We have change of x equals to t cubed minus 2t squared minus 6t. And then we substitute the value, which is at 3 seconds. We have change of x is equals to 3 cubed minus 2 times 3 squared minus 6 times t. We have change of x. 3 to the power of 3 is 27 minus 2 times the square of 3 is the square of 3 is equals to 9 times 2 is 18. 6 times 3 is equals to 18. Add this two term. We have 36. We have 36 minus 27 is 9. But 36 is greater than 27. We have negative 9. Change of x. We have meters. So this negative 9 meters, the negative sign here indicates that the particle is 9 meters to the left of the initial position. That's all.